Well, we've used solar to do work for us in the context of low quality, right? If you remember, the sun actually does a lot of stuff for us. In that case, it wasn't generating electricity, but actually, in a few examples, it was offsetting electrical usage, right? If we remember, illumination, clothes drying, cooking, and some other uses of low quality solar, water heating, right? In all of those cases, it's essentially offsetting electrical use, although it isn't actually generating electricity. So that's the primary distinction between low quality solar and then these other two types of solar that we're going to talk about, which do generate electricity. The first one that we're going to get into is what we call concentrated solar thermal, or heliostat, I guess is an example. Just as wave snakes were my favorite, this one is my favorite in the context of solar. So heliostat, when we think about what that word means, actually, you can see here, this is a beautiful rendition of the Greek god Helios, right? So if you've learned some stuff about mythology, every morning Helios has got his horses and his chariot, and they ride up over the horizon, and that's the sun, and then it takes him all afternoon, and then at the end of the day, he goes down the other side of the sky, and every day Helios comes for his visit. So Helios is synonymous with sun. Actually, here's a beautiful field of sunflowers. They have a particular behavior called, they're what we call heliotropes. And a heliotrope is a plant that will actually follow the sun over the course of the day. And if you've ever watched time-lapse video of a field of sunflowers, they do exactly that. The head of the sunflower turns each day, following the path of Helios across the sky, following the sun. So in this case, we're going to be talking about heliostat, concentrated solar thermal plant, and it's actually pretty ingenious, and it's not too different than that commercial example of a solar oven that we saw, which uses mirrors. So you can see this is the beginning of our heliostat plant, but it doesn't look like it's going to do much work for us so far. Essentially, what this kind of heat system looks like, or this electrical generation system looks like, is a primary tower, which is located in the center part of the facility, and there's a few different ways they work. Essentially, what we're going to do with this one is we're going to put in a heat exchanger, as drew it as a squiggly line, inside this basically kind of water tank. Although it's not actually filled with water, it's filled with salt. And salt, it turns out, has a fairly low temperature where it will convert from a solid to a liquid. So it's not unreasonable to basically make like the salt equivalent of a magma, what we would call molten salt. You got to get it really hot to do that. And then we essentially have cold water in. So cold water will ultimately go up and pass through this molten salt. And as it gains heat, that water gets hot and heads off to the hot water tank. So you might be asking, how the hell are you going to get molten salt? Well, of course, with the power of the sun. So the way that this works is there's a series of mirrors, these kind of parabolic dish-style mirrors. Each one, they're not a full dish, but each one is kind of shaped just the right way that as sunlight bounces off that surface, it's actually concentrated at the top of the heliostat tower. Not too different from the way that a lens will concentrate solar radiation to a point that's hot enough to burn an ant or write your name on a popsicle stick or whatever you do as a little kid. But here we have these heliostat reflectors. And so the thing that's collecting the sun and zapping it up to the top of this tower is not a photovoltaic cell. It's not a solar cell like you might be thinking of, one that's actually going to generate electricity. All this is a mirror. And individually, if we look at one of these kind of curved panels, internally they're made out of a whole bunch of smaller mirrors that are all kind of rotated and turned in just the right way. so that if any mirror were to break, it can be easily replaced. Now, the other thing is, remember I called these a heliostat, and I compared them to a sunflower. And so as the sun is passing over, as Helios is passing over the area for the day, these mirrors all rotate in an orientation that keeps that beam focused on the central tower, creating that molten salt. And so one of the interesting things is, at this point, we now have really hot water. At that point, we can kind of start our typical power plant story, where then this hot water would be used to create steam, spin a turbine, and that turbine spins a generator. So essentially what we've done in this situation is created steam again, and we've spun the magnet. So it is fundamentally not any different than coal or nuclear, but in order to heat the water up, we're actually putting in these mirrors that are coordinated. They're all in a computer program to keep the sun's beams focused on this molten salt. And this thing, which is different than other renewables, it doesn't just generate electricity at the instant. It generates electricity for about 12 hours. So because there's this thermal mass stored here, and there's thermal mass in this molten salt, even after the sun goes down, this power plant can continue to generate power. So I wanted to take a look at a couple of these. You can see here, most of the installations are out in the desert Southwest, although there's some notable ones in Spain and also in the Middle East. But you can see there's these vast arrays of mirrors. Each of those is what we would call a heliostat, focusing their solar rays on the center tower. So you can see, one of the things that people talk about is how if birds were to fly in the way, they could get fried. Famously, right, some detractors, some people who really, are against alternative forms of energy, talk about heliostats and how they're so dangerous for birds because they'll fry them. But, I think, when you start realizing, the amount of CO2 released, obviously it's a no-brainer. So again, these would be installed in places, if you think back to that map, or I guess we can take another quick look at it, where we have the highest possibility or the highest incoming solar radiation, particularly the desert Southwest. And the largest heliostat in the US generates a significant amount of power, and you can see it's actually 3 heliostat fields kind of all joined together. So this is a pretty cool solution. It's not as pulsed as other types of solar or renewables, where when the wind is really blowing, you get this energy pulse. When the sun is really shining, you get this energy pulse. Here, those spikes are a little more kind of doled out and distributed over time. They have a very large footprint, so that's something that people talk about as a negative. So they can apparently fry birds. Well, obviously they can make molten salt, so they could cook a chicken pretty easily. Again, they have fairly large footprints, but they're usually installed in fairly desolate desert areas. The other thing that people talk about is for the critters who live out here, the tortoises and the hares and the mice and the snakes and all of that all of those sorts of critters, they then live in a much more shaded environment than previous. So it does change the kind of microclimate of the area, because rather than that heat being absorbed into the surface of the earth, it's actually hitting these mirrors and being reflected and concentrated. So it can have a small economic impact, but glass and mirrors are super cheap and super easy to make. There's no electronics, right, other than the little motor that actually functions the heliostat. Each one has a small motor. Here we've got molten salt and cold water and hot water, so we need a water source, and then concentrating into steam, generating electricity. It's actually it's a pretty clean way to spin the magnet, and it actually could have it could offset an incredible amount of power. So these do generate significant amount of power. Although, like we mentioned before, one of the limitations with most solar technology is it's something that can only really be deployed in a specific area, right? We just have parts of the country where we can do this. So it's not something that you can put in, outside of Seattle, of course, right? We'd build it, people would come and look at it, but it wouldn't do anything. It would just sit there and be a tourist attraction for a little while until it all rotted away. So again, only in places where we get enough solar. But we'll see that that's less the case with the next topic, which is photovoltaic. So photovoltaic can actually run, at a little bit less wattage per square foot. The heliostat plant, in order to get that molten salt, needs an incredible amount of sun. So this really is something that's pretty limited. Although we're putting them in, right? We're installing them nationally to help offset the power we see on the grid. All right, so in the next video, we're going to start talking about photovoltaic as a power source.